Alright, bet. Welcome back, guys. Today we're going to be talking about pitting corrosion. Pitting corrosion is one of the more dangerous corrosions. It's when small, tiny holes um, get penetrated, get drilled on the surface. So let's get into it. So think of it like a cavity, right? You got the tooth, you keep eating really junk food, and sugar builds up on the surface, and then it keeps going down, 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 and gets drilled right in the middle of the tooth. So think about that the whole time, okay? So first of all, we have initiation. Initiation is when you have the surface and it gets scratched by aggressive chemicals like chloride or road salt or salt water, seawater. Okay, so the chemicals that are really aggressive scratch that metal surface. Second is propagation. Propagation is when the metal underneath gets exposed and that part becomes the anode because metal ions get lost at that spot, right? That little small hole. But then, so the anode is a really small site now, and the cathode is a really big site. Okay, so that small anode to big area of cathode ratio makes it more concentrated on one tiny spot. So corrosion becomes like way more amplified and magnified at that one tiny spot. Okay, that's why it's so dangerous because corrosion becomes really fast at a really tinier spot and it drills down. And last but not least, acidification. Acidification is when the metal ions it mixes with the water and the moisture and becomes HCl, hydrochloric acid. That's a really strong acid, and a really strong acid can make the corrosion rates faster, and by making it faster, it can drill down apparently 100 times faster than normal corrosion or normal rusting, 100 times. So that is really, really dangerous. So yeah, the main idea is basically the natural skin gets scratched by salt, and then once that tiny area is exposed, it becomes a magnet for acid and chemicals to stay trapped inside that hole, drilling deeper and deeper and deeper until the metal suddenly snaps or leaks catastrophically, really sudden. So that is the metal cavities. That's what pitting is. So how can we stop pitting? Lots of ways, lots of ways. First of all, cathodic protection. That's when you add like a zinc block, a sacrificial anode, so it could eat that block up and save that surface underneath. Another way could be better material selection. So we talked about stainless steel and chromium, having chromium in your steel. Having chromium in your steel is really good because it forms chromium oxide, which forms that physical barrier, that invisible oxide layer on top of your metal surface that doesn't allow any water or moisture to get in contact with the metal layer underneath. Another thing could be protective coating, right? We can add high quality paint, epoxies, or plastic linings, creating another physical wall that doesn't allow salt or moisture to touch the metal surface underneath. We can also control the environment in closed systems like boilers or cooler towers, adding inhibitors, chemicals that neutralize the acid to stop this reaction before it even happens. And last but not least is designing tweaks, avoiding crevices. We talked about crevices in the last video, those narrow gaps, any sharp corners where stagnant water can sit and get get salty to prevent any conditions that trigger a pit, right? We don't want anywhere to have like water just laying there all the time. So that is pitting corrosion in a nutshell. Thank you for watching my video. I'll see you guys in the next one.